This example is on page 343. It's about apgar scores. Now, babies take a test when they're first born. So this little guy, this poor guy is going to take a test. Welcome to the world, right? Here's your first test. Now, the test is in 5 different categories: skin color, heart rate, muscle tone, breathing, and response when stimulated. And they can get a score of 0, 1, or 2 in each of those categories. So for instance, a perfect score would be 10. And they still use this test. It was developed in 1952. Now, I asked my wife what our kids' apgar score was, and she said that she does remember them doing it, and the score was very high. She just doesn't remember what it was. Typical mom. Now, you might ask your mom or dad about your apgar score, and I bet you they'll probably say the same thing. Okay, so let's take a look at this. It looks like from the data, if we look at these probabilities, so the probability of each one of these scores, so it looks like a score of 8, or let's see, 8 and 9, lots of scores in the 8 and 9 range. 40%, 30%, almost 70% of the kids are in that 8 or 9 range, and then it drops off dramatically from there. And not very many kids get a 10, a perfect score. So, could you make a histogram of this on your calculator? That's something I'm not going to do right now. I wonder but could you do it? Okay, so the bars would be these probabilities. Okay, so what if we figure out the average score? And that would be the expected value. So remember, we multiply all of these, the scores times the probability, and then add them together. And that would be the average. And then the standard deviation of that as well. But I'm going to show you how to do it on the calculator. So we did that short one with only 3. That was the last video. So let me show you what it looks like on the calculator. So I went ahead and put the scores in list 1 and then the probabilities in list 2. You can't see all of them on the screen, but I did 1 through 10 and put all those probabilities in there. And so remember, you press stat and then calculate, and it's one variable statistics, and you should see the average and the standard deviation. But we have to be careful. There's one additional thing here. When we normally do this with just one list of data here, there's nothing in this here, in this frequency list. So here's our list of data, and how often does it happen? Well, these are the probabilities of how often that might happen in that list. So we're using these two, and that way the calculator can calculate that mean and standard deviation correctly. So don't forget that. So it looks like right here we have our expected value of 8.1. That's what we should expect a baby to be at. Actually, the average of all babies, right, would be 8.1. But that's our expected value. It should be somewhere around 8. And then we have, it seems like this is kind of a big standard deviation, so could go as much as 1.4 above or below 8. Okay, so there's that. So there's another example of a discrete random variable. Discrete meaning that they get a specific integer value. Right? There's nothing in between there for our scores. Also, there might be a question where it says, well, what's the probability that a baby has an apgar score of 7 or higher? So you would add all these together, right? That would be the probability that it's 7, 8, 9, or 10. Okay, now the next video is going to be about a continuous random variable. That's where we could have any value from, say, anything, but your scores could be anything between 0 and 10. So it could be like 5.49, something like that. Anyway, that's going to be on the next video. All right, so let's stop right there. See you later. Bye.